Hi everyone. So in this video we'll talk about recursive grammars. And what is a recursive grammar? A recursive grammar is a grammar which has for some production rule it has the same symbol on the left and the right hand side of the production rule. So if I have, let's say, something like ASB, so this is an example of a recursive grammar because I have S on the left here and the right here. So this is an example of a recursive grammar. And even within recursive grammars, there's something called a left recursive and a right recursive grammar. So let's talk about left recursive first. So left recursive. What the left recursive grammar means is that the leftmost symbol in my RHS is going to be the same symbol that I have on the RHS, the LHS. So if I have something like S goes to SA or epsilon, that's an example of a left recursive grammar. And similarly, an example of a right recursive grammar is if I have something like S goes to AS and epsilon. So that's an example of a right recursive grammars. And I'm not going to go too much in depth about left and right recursive grammars, but one thing that I'll just mention is that left recursion is not too great, whereas right recursion is alright. But more importantly, we talked about derivation trees in the last video. So we also talked about ambiguous and unambiguous grammars. And what I want you to remember is that if a grammar is left recursive or right recursive, it's not going to be ambiguous. But if it is left as well as right recursive, it's definitely going to be ambiguous. If it's neither, then I don't think anything can be said about it. But if it's both, then it's definitely ambiguous. And if it's just one of them, then it's definitely unambiguous. So let's consider a string. Let's just say I have AAA. And let's say I'm using the first grammar that's here, which is this one. So I'll underline this with with green, and this with blue. So if I use the first grammar that I have, I'll get S yields S and A. So SA right here, and the S, I have just one S now, so that's going to yield an S and an A, and this S is going to yield an A. So that's the derivation tree that I get using the first grammar, and that isn't going to change whether I use a leftmost derivation tree or a rightmost derivation tree, because at each step I just have one option of the S which I can split into S and A. So that's how I make the first derivation tree. So I hope I've convinced you that this grammar right here is indeed unambiguous. And for the second one, what's going to happen is I'll have an S which splits into an A and an S, and once again I just have one S here which will split into an A and an S, and this S will split into an A. So this is the derivation tree which corresponds to my right recursive grammar. So once again, at every step I just have one non-terminal which I can expand. So I hope you've understood that these two are derivation trees for different grammars. So one of them is for this one right here, which is a left recursive grammar, and the other is for this one, which is a right recursive grammar. So for each of them, there's no option that I have. This is the only pass tree that I'm going to get, which means that each of these is actually an unambiguous grammar, which conforms to what I said earlier, that if a grammar is only left recursive or it's only right recursive, then it's definitely unambiguous. Whereas the example that we saw last time was S goes to SS or A. So this was in fact both left and right recursive. So if something is left and right recursive, it's definitely ambiguous. And if you remember, we did see that this was ambiguous in the last video. So that's about recursive grammars. I'll see you next time, but in the meanwhile, don't forget to give this video a thumbs up if you understood recursive grammars from here. And don't forget to share the video with your friends so that they can also learn. And if you haven't hit the subscribe button, hit the subscribe button so that you know when the next video is up. I'll see you next time.